Namaskar, this is Nayan and I welcome all of you to my new lecture series. Students, in my previous 6 lectures, I solved a total of 30 problems from SLET 2024 Physical Science paper. Today also, I will continue this journey by solving another set of 5 problems. So, without further delay, let's get started. Problem number 31. This problem number 31 is also assertion reason type problem. First, let me read the assertion and reason statements. Assertion: there was a need to unify quantum mechanics and special theory of relativity into a simple relativistic quantum mechanics, and Klein-Gordon derived the relativistic equation. This is true statement. The Klein-Gordon equation is indeed a relativistic quantum mechanical equation that was developed to unify quantum mechanics with special theory of relativity. Next, reason: the Schrödinger equation is not invariant under Lorentz transformation as it is non-relativistic. This is also true statement. The Schrödinger equation is non-relativistic and it is not invariant under Lorentz transformation. As a result, relativistic equations like Klein-Gordon and Dirac equations were developed. So, after analyzing, we have seen that both assertion and reason are true. So, therefore, the correct answer of question number 31 is option B. Both assertion and reason are true. Okay? Now, let us move to question number 32. This is also assertion reason type question. Assertion: fermions show the property of odd parity. This is false statement. Okay? Now, let me show you how this is a false statement through one example. Students, we know that these fermions are the particles having half odd integral spins, and some examples of fermions are leptons and anti-leptons. These leptons have even parity and anti-leptons have odd parity. So, from this example, we can say that the fermions can have both even as well as odd parity. So, therefore, this is a false statement. Now, let me write these points. Leptons have even parity. Anti-leptons have odd parity, and these leptons and anti-leptons are the examples of fermions because they are spin half particles. Okay? So, from this example, we can say that these fermions can have both even as well as odd parity. So, assertion is incorrect. Next, reason: odd parity is the characteristic feature of all integral spin particles. Here, integral spin particles means bosons. This is also false statement. Okay? Odd parity is not the characteristic feature of all bosons. These bosons can have both even as well as odd parity. For example, the bosons like photons, gluons, WZ bosons have even parity, and the bosons like pions, kaons and eta have odd parity. So, from this example, we can say that the bosons can have both even as well as odd parity. So, therefore, this reason is also false. Now, let me write these points. Bosons: the bosons like photons, gluons, WZ bosons have even parity. The bosons like pion, kaon and eta have odd parity. Okay? These photons, gluons and WZ bosons are spin 1 particles and pions, cations and ether are spin 0 particles. Okay? So from this example we can say that this region is also false. So after analyzing we have seen that both assertion and region are false. So therefore the correct answer of question number 32 is option B. Both assertion and region are false. Now let us move to question number 33, and according to this question we have to match the items of column number 1 with column number 2 to identify the correct answer code. Diamagnetic substance. Students, we know that diamagnetic substance are characterized by net zero magnetic dipole moment. So if we look at these 4 options, only option 1 gives net zero magnetic dipole moment, because the magnetic moment of first dipole is cancelled by the magnetic moment of second dipole, the magnetic moment of third dipole is cancelled by the magnetic moment of fourth dipole, and so on. So therefore option 1 represents the property of diamagnetic substance. Okay? This one. Next, paramagnetic substance. Again we know that the paramagnetic substance is characterized by small net magnetic dipole moment in presence of external magnetic field. So if we look at these 3 options, then we have seen that option 2 gives small net magnetic dipole moment, and this small net magnetic dipole moment is due to dipole number 3 and dipole number 4 only, because the magnetic moment of first dipole is cancelled by the magnetic moment of fifth dipole, the magnetic moment of second dipole is cancelled by the magnetic moment of sixth dipole. So therefore option 2 represents the property of paramagnetic substance. So B is related to number 2. Next, ferromagnetic substance. Again we know that ferromagnetic substance is characterized by ferromagnetic domains in which the magnetic dipoles are strongly aligned in a particular domain. So if we look at option number 3, we have seen that the magnetic dipoles are strongly aligned in a particular direction. So therefore option 3 should represent the property of ferromagnetic substance. So C is related to number 3. The last one is ferrimagnetic substance. Students, we know that ferrimagnetic materials or ferrimagnetic substances are those substances in which magnetic dipole moment of nearest neighbor atoms are not equal but they are antiparallel. So if we redraw these magnetic dipole moments, then we will see that this option number 4 will represent the property of ferrimagnetic substance. Okay? So D is related to option 4. Now let us redraw these magnetic dipole moments. The resultant magnetic dipole moment of these 2 dipoles will be in upward direction, and the magnitude will be 2 times of one dipole. Next one is this dipole. Again the resultant magnetic dipole moment of these 2 dipoles will be this one. Next one is this one. Again the resultant magnetic dipole moment of these 2 dipoles will be along this direction. So here we have seen that the magnetic dipoles of nearest neighbor atoms are not equal but they are antiparallel. So option 4 represents the property of ferrimagnetic substance. So after analyzing we have seen that A is related to 1, B is related to 2, C is related to 3 and D is related to 4. So therefore the correct answer of question number 33 is option A. A is related to 1, B is related to 2, C is related to 3 and D is related to 4. Okay? Next, let us move to question number 34. This question number 34 is also assertion region type question. Assertion: in atomic physics, the fine structure describes the splitting of spectral lines of atoms due to electron spin and relativistic corrections. This is true statement. Students, we know that the fine structure of atomic structure lines arises from the interaction of electron spin and its orbital motion around the nucleus, as well as relativistic corrections to the electron's motion. Reason: the fine structure energy corrections are obtained by perturbation theory. This is also true statement. The perturbation theory is often used to calculate fine structure energy corrections. So, after analyzing, we have seen that both assertion and reason are true. So, therefore, the correct answer of question number 34 is option B. Both assertion and reason are true. Finally, let us discuss question number 35. This is also assertion reason type question. Assertion: radioactive emissions alpha and beta ionized gases. This is true statement. Of course, alpha and beta particles can ionize gases. Since the charge on alpha particles is higher than the charge on beta particles, so the ionizing power of alpha particles is higher than the ionizing power of beta particles. Reason: all the three radioactive decays, namely alpha, beta and gamma, ionize gases. This is also true statement. The alpha particles have highest ionizing power and gamma rays or gamma radiations have lowest ionizing power. Now, let me write the ionizing power order here. Ionizing power order. The ionizing power of alpha particles is higher than beta particles than gamma rays. Okay. So, after analyzing, we have seen that both assertion and reason are true. So, therefore, the correct answer of question number 35 is option A. Both assertion and reason are true. So, this is all about today's video, and I hope that you have learned a lot from this video.